Hi there. I'm just going to run this quick demonstration to show how eTool can be used for modelling and improving the life cycle and environmental impacts of infrastructure. So it's a little bit clunky using eTool for infrastructure because most of the user entries to set your project up are based around buildings. So it'll ask you questions centred around the floors and the roof, etc. And you just kind of ignore that and push through it. Once you're actually entering materials and labour and equipment, etc., everything's totally robust for infrastructure. But I just thought I'd flag that up front. We will be making changes to the user interface to make that more intuitive. Anyway, we've got this rough model here that we've done for the Sydney Harbour Bridge, and I'll just run through that very quickly. So we've got over here, you can see 230,000 tonnes of CO2 relating to the materials, predominantly steel and concrete. Some equipment usage here, some transportation of that equipment and labour and materials to the site, and then also some recurring impacts over the life of the bridge, the maintenance of the bridge, the replacement of the steel parts, the replacement of the paving on the road, etc. The repainting of the bridge, which makes up quite a big proportion of this. If we just navigate to the external finish area, you can see that there's 14,000 tonnes of CO2 wrapped up in repainting the steelwork, which effectively gets repainted every 30 years. So we can model improvements. For example, if we were able to find a paint that actually lasted for 40 years instead of 30 years, then we would get an improvement there. I'm just going to reverse that because what we normally do when we start modelling improvements is actually clone the design so we can see the difference between our base design and our improved design. So I'll just very quickly now remodel that improvement. So all this is about doing is really just selecting a better technology that's going to last longer. This is, I guess, the entire coating of paint, which would be removed, the whole 3 coats. And if we can just make that, make that last 25% longer, on average, then we'll get a pretty significant improvement in the life cycle performance of the design. The other thing we could look at is actually swapping materials with lower carbon alternatives. So a classic there might be actually looking at whether we can't introduce waste material into the concrete, like blast furnace slag or fly ash. So hopefully we've actually got one with the same amount of reinforcement in it, and we do. So let's say 50% blast furnace slag, and we swap all the footings out with that, and we get a small improvement. It's not huge, but there is definitely an improvement there. If we look at fly ash, it's a slightly bigger improvement. So maybe in this case we'll actually run with the fly ash. Just confirm that change. You want to be careful when you're running these changes that you don't end up sourcing that material from further afield. If it comes from further away, it may offset that improvement. And we could actually model that. We could actually say in here, okay, let's actually go to that this concrete that we've just swapped out. We might actually say that it's not 113 kilometres by truck. It's actually 150. And we'll see a change over here. So we can see here that at the moment the total CO2 relating to this section of the design is just under 300,000 tonnes. By changing the mode and length of transport, we can see that it's actually increased slightly, which would have reduced the benefit of selecting that fly ash concrete. I think those transport distances that we just looked at there are way off. They're probably way too big. You'd expect them to be a lot smaller than that for concrete. However, we're just running with this at this stage for the purposes of demonstration. The other one might be steel. So we could look at some recycled content steel. And there's a lot of conjecture in the LCA community about whether this realistically does lead to a net difference in society, and the reason being is that recycled steel is fully allocated. It's not a case of it's very difficult to drive more demand for recycled steel by purchasing it. It's already got, it's already fully allocated, and the collection rates are actually really high, so there's not a lot of extra recycling of steel that can occur even if the demand increases. However, for the purposes of this, we'll assume that we can claim the benefits of the recycled steel, and we'll swap this out. So we've made a couple of little changes there, and we can navigate back to our structure, and we can compare these two designs. And you can see there that we've improved the CO2 performance of the building by around about 30%, with no effect on the functionality. Probably an increase in costs, I would imagine, and we can quantify those in eTool as well if we want to understand what the bang for buck is. What I haven't demonstrated in this is all the neat templates that eTool has that enable you to, further improve the design. One that springs to mind would be utilising this infrastructure, or the energy potential of this infrastructure. So it's a huge support base that could be used to actually generate renewable power. PV would work. I don't expect that we would be so amped about covering the Harbour Bridge in PV anytime soon, but for the purposes of demonstration, let's just have a look at what happens if we add some solar cells to the bridge, or a solar system to the bridge. And we'll assume a 1 megawatt system, which I think would fit fairly comfortably on that structure. I'd have to double check the figures there, but and you can see there that has actually pushed the structure into a net zero carbon position. So in this case, the bridge would be exporting enough electricity and reducing the carbon intensity of other people's electricity, to the extent that the materials, or the embodied carbon of the materials, added up to less than the offset electricity. So that's a kind of interesting little sort of side note, in this demonstration, and the reason I did that was to show you what's involved with the templates. So in this particular template, we've got the assembly related to the installation of the solar system, the services. So the actual this is the materials wrapped up in the service. So your panels, your inverter, and your frames, and we've also got the generation, so the actual energy generated by those cells, or by that system. So it's really nice that all you have to do is know what size system you want to put in your design, and eTool automatically calculates the rest for you because of this templates library. And the templates library is very extensive. It's a little bit limited for infrastructure at the moment, but it's definitely growing, and it's very comprehensive for buildings. So just about any normal building component, you'll find a template for that in eTool. That pretty much wraps it up. I hope that made sense. Thanks.